Hello, my name is April King. I am representing Group 4 for MAT121, Algebra and Trigonometry. We are working on a stormwater management activity. I will attempt to go through the calculations that were used in order to answer these questions. So we have been hired to run the analysis for the pre and post development peak runoff of the stormwater. As we see, this will be done for South Lakes Elementary School. So number one, we had to identify the variables in the C function as a dependent or independent. And we had to identify if the variables in the Q function is dependent or independent. We also had to explain how does the role of the C variable change from the first function to the second. So function C we determine is a dependent function. The variables such as the runoff coefficient of the soil type and of the area of the soil type are independents. Function Q is a dependent function because the variable's weighted average of runoff coefficients in the total area and in rainfall intensity of the design storm is a constant. But it of course depends on the storms and the times. In the first equation, C was a function that is dependable, and the C became an independent in the second function. Number two asks if based on the images of the pre-development and post-development of South Lakes Elementary School, do we anticipate a stormwater management system being needed? And yes, we did, because the first image, there's no drainage system and it's mostly clay. So in the development plan, you have to have and create a drainage system in the stormwater management, especially here in North Carolina. We see that the peak design storm for North Carolina, Wake County specifically, was 7.08 in an hour. In the second image, you can tell that there is a system because we have 8.7 wetland drainage area of 6 acres that was asphalt. And you can see more runoffs in that area also. We determined if the pre-development runoff coefficients for the marked area in number 3. So we took A as the surface type of heavy soil, which was 3.30 acres, and the rational runoff coefficient of C1, which was 0.2. The surface type was average heavy soil. So AT was 0.20 acres. The rational runoff coefficient of C2 was 0.1. So doing the calculations, we came up with C equaled 0.19. For number 4, we had to determine the pre-development peak runoff for the marked area. We utilized the formula Q equals C times I times A, and we came up with Q equaling 4.75. We had to determine if the post-development runoff coefficient for the marked area for number 5, and we utilized the formula here. Well, here. Surface type asphalt, A1 was 6 acres, and the rational runoff coefficient of C1 was 0.95. The surface type for B was landscaped, and so we utilized A2 to equal 2.70 acres, and the rational runoff coefficient of C2 was 0.35. After doing the calculations, and I'll just run off an example. So we did C equals A1 times C1 plus A2 times C2 divided by A1 plus A2 equaling 6 times 0.95 plus 2.7 times 0.35, divided that by 8.7, which equaled 6.645 divided by 8.7. And what we received was an answer of 0.76379, rounded off to 0.76. We were also asked to determine if the post-development peak runoff for the marked area for 6, we utilized the formula Q equals C times I times A again, and computed an answer of 47.20 cubic feet. We then analyzed our results to determine if a stormwater management system is needed. When we compared the pre-development and post-development results, we see that the peak runoff in the post-development is 10 cubic feet higher than the pre-development. So we definitely need a stormwater management system in there. The peak runoff in the post-development was 47.20 cubic feet. And for pre-development, it was 4.75 cubic feet. It relates to our recent topics in class because we're studying functions and variables and dependent or independent variables. This is an example of a two function, which is represented with two equations, which would be this formula. Using that formula, C equals the sum of AICI divided by sum of AI. That's the weighted average of the runoff coefficient. The equation for the peak runoff equation would be Q equals C times I times A. So after running these equations, I definitely was piqued in the fact that we could utilize this information and looking at pre-development plans and determining how one